Alright, what you're looking at there, see there's some very cool clouds in the sky, and you're going to notice that the front of the clouds and the sides are white, but one side is white but the other side is dark. So the question is, why is that? And so it's actually something that's very interesting. Okay, so your first guess might be, well, because it's not getting any light. But actually, that's not the real reason. What happens is that as the sunlight goes through the clouds up there, it hits the water droplets in the clouds, and the light gets scattered out. And as the solar beam continues through the cloud, more light gets scattered out and more light gets scattered out. So that by the time the beam leaves the backside of the cloud, there's no more light to come out. All the light has been scattered out. Now, if you were to look at any thin slice of the cloud, there would only be a little bit of scattering. These are what we call weak scatterers. But when you pile a bunch of weak scatterers together, eventually the weak scattering leads to enough light coming out that what you see is the side of the cloud is dark. If you were to look at the clouds at noon, again, you would see the top of the cloud was white and the bottom of the cloud was dark. Again, the top of the cloud is white because it's scattering light in all directions. And that light, as it goes through, the solar beam as it goes through the clouds, gets more and more scattered out, and more scattered out, until finally what you're left with is just this dark side of the cloud. So a bunch of scattering eventually can give you the same thing as if these clouds were made of ink. Then, if the clouds were made of something like ink, for example, something dark, it would absorb all the energy. But the net result would still be the same, is that the backside would be dark. Doesn't matter whether the energy is absorbed or the energy is scattered, it's leaving the beam, and there you have it.